In this lesson, we will be learning about titrations. So the objective is to apply the concept of pH. You already learned what pH means to acid-base neutralization reactions. So in this titration, we're going to use the concept that if you have an acid, for example, hydrochloric acid, and base, for example, sodium hydroxide, when you do a double replacement reaction, the H and the OH becomes water and salt, NaCl. So the net ionic equation for this would be H plus. The Cl minus is a spectator ion. OH minus. Pretty much you're just making water. Therefore, the acid and base were neutralized. Okay, we're going to use that concept to do titration calculations. So first, let me tell you what titration is. Titration is a procedure to find the concentration of something you don't know using a solution, another solution that you know. Okay, an example would be, let's say you don't know the concentration of an acid, then you would add a base to it where you know the concentration of that base. So a couple glassware that we'll be using. First, we're going to be using a burette. A burette is, if you think about it, a very long graduated cylinder, but thinner than that. So it has more accurate. You can fill it to about 50 milliliters of water. So if here you can add 0 milliliters, and then if you keep adding all the way down, you can go all the way down to 50 milliliters. Okay, so first you're going to start with adding a liquid in there, a solution in there, whatever it is you decide. And as you open this valve can open or close. As you open it, the solution will go down into your beaker or flask in the bottom. Okay, so the burette, you would put something in there that you know of. Let's say we put some sodium hydroxide. So let's say we use 0.10 molar sodium hydroxide. So you know the molarity for this solution. And I'm not going to go ahead and draw the sodium because they're spectator ions. I will just put hydroxides inside this. Imagine a bunch of hydroxides. Okay, coming out as you open the valve, you're going to be putting hydroxide in here. Okay, that's your burette. So inside the flask or the beaker, this one is the beaker, you're going to put a solution that will react with the hydroxide. For example, hydrochloric acid. Okay, hydrochloric acid is a strong acid, therefore it will always ionize into H plus and Cl minus. I won't draw any more of the Cl minus, they're spectators. Let's just put I have a whole bunch of H pluses in there. And I don't know how many there are. So in this solution is your unknown. In this solution is your known. Because you know what the molarity is and you know how much you're adding. Here you don't know. Okay, and so what you're going to do, but you know it's an acid, so it's HCl, but you don't know what the molarity is. Okay, so what you will do is you will, of course, you're going to add the OH minus to the H plus, but you have to add an indicator, something that would change colors so you know that you have matched the amount of H and OH. For this one, we're going to go ahead and use phenolphthalein. Phenolphthalein. Okay, as you remember, phenolphthalein turns pink when the solution turns basic. Okay, so here we go. And for the unknown, you have to know how much volume you're going to add. Let's say we use 10 milliliters. You can measure the volume of that even though you don't know the concentration. Okay, so you're going to open the valve. You're going to add the OH. As the OH meets the H, this OH will neutralize this H plus. This OH will neutralize this H plus. So you're going to need more, so you can just keep adding. Okay, and you're going to need 2 more. Say there's 2 more. Okay, so this OH will match this one. This will neutralize this one. Okay, and so what happens here, you have equal moles. Okay, so when you have equal moles of H plus or HCl and OH minus, This is called equivalence point. Equivalence point. Because the acid and the base is stoichiometrically equivalent. Okay, so what happens is if you just add one more drop of OH minus, let's say one more OH minus, then you're going to have an OH minus here. Because it's now basic, the solution will turn pink because you put an indicator. As soon as it turns pink, you stop adding the hydroxide. Okay, so that tells you that you have equal amounts of the moles. Equal moles. Let's say that you kept adding and you ended up adding all the way down here. So this is all gone because the liquid kept going down. And now you have you added 16 milliliters of the base. Now that you know how much you added, you can do stoichiometry. Okay, so once you know how much reacted, use stoichiometry. First, you have to write the equation. Then you have to write everything that you know. Okay, first, you know that you have 0.1 molar NaOH. You also know that you added 16 milliliters of it. Okay. You don't know the molarity of HCl because it's your unknown. And you know that you added 10 milliliters of it. Let's give this one more sig fig, 16.0. So now your goal is to find the molarity of the unknown. So you're going to start with what you know, get to moles, go across, and then go back up. Okay, so I'm going to start with a singleton here. The singleton is 16.0 milliliters. I'm going to start way over here because I need more room. 16.0 milliliters, turn that into liters. 1,000 milliliters is 1 liter of NaOH. Okay. Okay, this molarity means 0.10 moles for every 1 liter. Okay, so this means 0.1 mole for every 1 liter. And you can flip that as a conversion factor if you need it. And this is NaOH. By doing this, you're going to cancel the milliliters, cancel the liters, and now you have moles of NaOH here, right here. Then you're going to use the balance equation. I think this is a 1, 1, 1, 1. To go mole to mole ratio to get the moles of this one. So you have for every 1 mole of NaOH, you're going to get 1 mole of HCl. Okay, then you do this calculation. 16 divided by 1,000 times 0.1 equals 0.0016 moles. I'm not doing sig figs here, just giving you the concept right now. 0.0016 moles of HCl. Now the question is molarity. What is the molarity? What is the molarity, question mark molarity of HCl? Well, the molarity is equal to moles of HCl over liters of HCl, right? I know the moles, that will go there, 0.0016 moles. And I know the liters, that changes to, let's change that to liters. 1,000 milliliters is 1 liter, so it's 0.0100. 0.0100 liters equals. That equals 0.16 molar HCl. So what just happened here is we found the molarity of something we don't know. So let's just review again. What is titration? Titration is a procedure for determining the concentration of your unknown using a solution that you know of. In this case, we know that NaOH is 0.1 molar. We reacted it with the unknown, which is HCl. Now we know that HCl is 0.16 molar. Okay, and that's what titration is. A couple more things that I forgot to add is that your Your known solution is sometimes called the titrant, and your unknown solution is sometimes called the analyte.